Our censorship and propaganda video series teaches you how to identify and circumvent censorship and propaganda that cost you time, money, liberty, and sometimes your life, and find the products, services, leaders, and public policy that work better, cost less, and empower you. Quantum Mysticism. Can you make your life better just by wishing hard enough? Quantum mysticism is a genre of popular mysticism that generally purports, like the movie on the left, What the Bleep Do We Know from 2004, that quantum mechanics, the prevailing theory of atomic and subatomic physics, one, includes the idea that your consciousness, your thought, your will can influence or even control the external world, and that through the application of your mind, your will, your wishing, in fact, you can make your life better, you can heal yourself of disease. There's a large genre of this type of quantum mysticism exemplified by What the Bleep Do We Know, by Deepak Chopra, and quite a number of others. How true is this? What is quantum mechanics? Quantum mechanics is the theory of very small objects like the hydrogen atom, hydrogen being one of the main constituents of water and believed to be the power source of the sun. The hydrogen atom is very small, invisible to the naked eye or even the most powerful microscopes. It's about 1/millionth the width of a typical human hair, about a 10,000th of a micron, and a micron is the size of a small bacterium, about a tenth of a nanometer. It's smaller than the wavelength of visible light. In popular science, hydrogen is often presented as a sort of miniature solar system, as are other atoms, with a nucleus, and in hydrogen it's very simple, containing a positively charged particle called the proton, and an electron, a negatively charged particle, orbiting around it. This image is known not to be true. It's a simplistic model of something that is in fact extremely confusing. And numerous hard-to-explain phenomena were observed studying atoms and very small-scale electrical phenomenon over 100 years ago, culminating in the development of quantum mechanics. Naively, as in our solar system model of the atom, we might think that tiny subatomic particles like protons and electrons and many others like neutrons and neutrinos and X-rays, that these would behave like billiard balls or baseballs or ping pong balls in the everyday world, traveling in straight lines, bending under gravity a little bit. This is in fact known not to be true, and this is one of the puzzles that led to the development of quantum mechanics. This is something called the two-slit experiment, and it started out as a mental experiment, a thought experiment, to try to explain quantum mechanics in classrooms. But experiments like this have actually been done since 1972, where the particle gun could be a laser, it could be a radiation source. What's critical is that it produces a very small number of the particles, like electrons for electrical charge or photons for light, at a very low level, where you actually see an individual hit or an individual light on a detector plate. In the old days, like the 1920s, this was actually photographic film. In fact, it could be a plate of glass with silver nitrate on it. Today, it's a video camera like in your smartphone. So if you keep running the particle gun, naively, this is what you would expect to see. The particles traveling in a straight line from the gun and forming two peaks over time. That's not what we see. That's not what happens, however. Instead, we see some very, very strange behavior. So this is what actually happens. We get a hit here, for example, as if the particle had somehow traveled right through a solid wall here. And let's keep doing it to simulate what we would actually see in a two-slit experiment. We actually get a pattern of peaks, not where we would expect to see them, and it looks like an interference pattern. Even though we see actual points on the detector, actual flashes of light, actual tiny little dots on photographic film. But somehow there's an interference pattern, as if waves are interfering. and somehow producing these particles. That is extremely puzzling. Quantum mechanics is full of strange behavior like this in many other contexts, such as the spectrum of the hydrogen atom or other atoms. Many other phenomena at this atomic level are completely counterintuitive. They can't be easily explained, well, can't currently be explained by Maxwell's equations by themselves, the theory of electromagnetism at room sizes in normal life. So what does it mean? In the 1920s, a theory was developed of quantum mechanics, and there was debate over how to interpret this wave-like behavior. And on one side, loosely, you had Einstein, de Broglie, and Schrodinger, who had basically an idea that came to be known as the pilot wave. They weren't very sure of this. They felt like we don't fully understand what's going on here, and in this they were probably correct. On the other hand was a large group of people led by Max Born at the prestigious and influential University of Göttingen, and Niels Bohr, who had his own institute in Copenhagen in Denmark. And they constructed that is the dominant version of quantum mechanics, the Copenhagen interpretation, after Bohr's institute, of what was happening. Well, what did they say was happening? Well, Max Born is principally responsible for this interpretation. What was waving, and how could it give rise to localized, what looked like particles hitting the detector plate? Born envisioned a wave, a mysterious distributed wave coming out of our particle gun and traveling through and spreading outwards from the two slits. The waves would interfere and produce an interference pattern, which would then interact in a mysterious way, which is usually called a measurement or an observation, with our detector here. So here, for illustrative purposes, the wave impacts the detector plate, and something that Born and Bohr never really explained very clearly. They just sort of waved it away and said there was a measurement, something like that happened, and something magical happened. The wave would collapse, perhaps like a expanding balloon popping, and shrink to a single point where you would see the particle, an electron or a photon with light or other subatomic particles. This is the probability wave idea developed by Max Born, and that is the dominant theory of quantum mechanics. So what was the observation? What was the measurement? That was and remains a puzzle, exactly how to define this. They were hand-waving this away. It was never put into a very clear form. One idea, which is not the idea of mainstream quantum mechanics, not what Born was thinking or Bohr was thinking, is the observer. The conscious mind is somehow the measurement and causes it to pop. Schrodinger didn't buy this at all, and he constructed a famous thought experiment. I don't think it's ever been done, not exactly as he described anyway. But he envisioned a poor cat put in a box. Inside the box is a radioactive source that's supposedly governed by quantum mechanics, a sensor, and the sensor, if it's fired by a radiation count, by the radiation hitting the sensor, will trigger and smash a vial of cyanide, of deadly poison, killing the cat. So the quantum mechanical interpretation of this in terms of a probability wave is at some point in the process, seemingly, we have a probability wave with a live cat and a dead cat at the same time. This persists until the mysterious measurement or observation happens. Where does that happen? How do we define that? The theory doesn't really explain that, and that was one of the problems Schrodinger was really concerned about. Maybe it happens when the radiation hits the sensor. Maybe it happens when we open the box. Maybe it happens when we look at the box. Maybe it happens when our conscious mind somehow apprehends the cat. That's a theory that's not the mainstream theory, but some physicists wondered if consciousness could play a role. It's one step from that to could wishing save the cat? Could we, by our mind, not just somehow trigger the collapse, but control or influence its outcome so the cat survives if we want the cat to survive? That is not the mainstream theory of quantum mechanics. It's not what Schrodinger and Einstein were getting at, but it's out there and forms the basis of the quantum mysticism. The simple answer is in most versions of quantum mechanics, no, your wishing cannot save the cat. That's not the theory. as presented in movies like what the Bleep Do You Know or Deepak Chopra or some other sources. Okay, now it's remotely possible that consciousness is involved, but that isn't the mainstream theory. We can also say that the effect, very likely if it does occur, and there have been attempts to measure it in parapsychology, must be very weak and erratic, unpredictable. So Robert John at Princeton University did a series of experiments with radiation-driven random number generators not killing cats, where he tried to observe and claimed to observe a weak effect of the mind. That is very controversial. It's never been generally accepted, and parapsychology research is not generally accepted by physicists in the scientific community. I don't really want to go further into that, but even if the things claimed by John and other parapsychology researchers in general were true, they're talking about an extremely weak, unpredictable, unreliable phenomenon. So maybe if you were wishing really hard, you might slightly change the odds that the cat would die or live from true chance without our will being involved. That's the very best that you could get from what we currently know. Nothing like the sort of miraculous results in your life implied in what the Bleep Do You Know or some other quantum mystic processes. Well, what did Schrodinger and Einstein, what were they thinking about? They felt they didn't understand quantum mechanics fully. We needed to drill down deeper to understand what was going on. There was a deeper level of some sort, a substructure to these particles, and they focused on an idea that came to be known as the pilot wave. And that is that, in fact, there is both a wave, shown here with the green lines, and a physical particle that has a specific trajectory. The particle moves somewhat randomly under its own power and is guided by this wave. It has some similarities to the idea of a surfer on a wave. In other words, the surfer has a very specific location, it's a very specific particle, but the wave is forcing him forward. A surfer on a wave works by physical force of the wave pushing the surfer forward. In contrast, the pilot wave is more like a radar wave being used to guide a drone, for example, to perform some task, basically a glorified model airplane or a device like that. It's more like that, where the radar wave is diffracting and interfering with itself and therefore producing some strange behavior in the flight of the drone. So what happens? Well, the wave progresses, the particle, for example, an electron or photon, follows it. But the particle actually always has a definite position. There's no pop, there's no collapse of the wave function, and this physical particle is what hits the detector and produces the signal, produces the hit, the flash of light. And this is the pilot wave interpretation. It's completely mechanistic. Your mind is not controlling what's happening here. This mysterious wave is what's doing it. It's produced somehow in association with the particle in the particle gun. And that's the pilot wave theory. The pilot wave theory is not the mainstream theory, although it has a physical appeal that the mainstream theory doesn't have. And it doesn't require this mysterious, faster than light collapse of the wave. Now, it's very likely, despite the dominant position of the Copenhagen theorem, that it is incomplete in the sense that Einstein meant in his famous paper in 1935 with his colleagues Podolsky and Rosen. Here he says, this is in the U.S. Physical Review, can quantum mechanical description of physical reality be considered complete? And it's likely that his complaints are valid, that we need to do something to make quantum mechanics complete in some way to resolve, in the case of the mainstream theory, what exactly is meant by measurement or observation. So the issue is not that there isn't some unknown there in quantum mechanics. Yes, there probably is, even though some prominent physicists claim that's not the case, but it's very likely that there is. However, consciousness, the human will, this magical behavior, wishing will make it true, isn't required for any of this, as the pilot wave demonstrates. The wishing is not enough. Wishing probably has a very small or no effect, and I'm being very generous here in saying that it might have a small effect that's pretty negligible. Quantum mysticism is very much unfounded in mainstream quantum mechanical theory. And folklore and tradition and philosophy are full of warnings about the dangers of relying on wishing instead of hard work, careful thought, logic, and reason. So quantum mysticism is to be taken not just with a grain of salt, but a very large block of salt. Our censored search website and service enables you to search censored and shadow banned websites for suppressed information. We offer transparency on what the search ranking algorithms are doing and tools to help you separate fact from disinformation. We offer both a free service for everyone and a paid professional service with full access to our tools and the ability to customize the search algorithms for your needs. Our business model is end-user funded to avoid either direct control or subconscious bias from advertisers. Our censored search service is intended as a complement to increasingly censored, advertising-funded search engines, such as Google, Yahoo, Bing, and even DuckDuckGo, which appears to be increasingly shadow banning alternative content. We cannot duplicate many useful features of the advertising-funded search engines yet, nor is this needed. Use our search engine for censored and shadow banned content. Get the other side or sides of the story. Remember, there are often more than two sides to a story. Inclusion in our search engine is not an endorsement. We include sites based on evidence of censorship or shadow banning in our judgment. We attempt to be neutral and provide tools to our users to evaluate and verify the content without relying on our fallible judgment. There is evidence that powerful interests actively spread disinformation to alternative sites to make identifying suppressed factual information difficult and discredit factual information through guilt by association. We are developing tools to fight these active disinformation tactics. Give us a try at censored-search.com, censored-search.net, or censored-search.org. We welcome constructive feedback. How can we serve you better? Bookmark our site as the censorship is growing by leaps and bounds. You may need us more in the future. Let your friends and colleagues know. You can access more advanced features and support development of a transparent, verifiable search engine that works for you and not giant advertisers such as Big Pharma by becoming a paid subscriber. If you want to support our development work, subscribe now.